Hello and welcome to this session in which we will discuss variable sampling. Variable sampling is also called estimation sampling. It's a substantive testing technique that the auditor used to estimate the dollar amount. Simply put, we're doing some substantive testing. For what purpose? To determine whether an account is fairly stated or not, whether account receivable is fairly stated, whether inventory is fairly stated. The truth is the auditor does not know the true average misstatement or the distribution of the misstatement or the true audited value of the population. So that's why we sample, but we really don't know the actual. Actual means true. We never know the truth because we don't examine everything 100%. So we only test a sample and we use statistics to estimate the characteristic for the entire population. So this is what we have to live with as auditors. A sample, we're going to use the sample plus some statistics to make a decision to help us decide whether the balance is fairly stated, quantify the projected misstatement and compare that to the tolerable misstatement and decide whether to accept or not. Now, to make these estimates reliable, to make those statistical estimates reliable, we have to rely on statistical concepts like the standard deviation, the standard error, the confidence level, the sampling distribution. All these terms you should be familiar with if you took statistics, basic statistics. Those are the foundation for what we're going to see later: ratio estimation, mean estimation, difference estimation. But before we dive into those different type of variable testing that I just mentioned, in this session, I want to set the theoretical background. I want you to understand why ratio testing work, or ratio estimation, or difference estimation, because we rely on statistics. Before we proceed any further, I have a public announcement about my company, FarhatLectures.com. Most students and CPA candidates struggle not because audit is too hard, but because it's taught fast and the logic behind the procedure isn't explained clearly. Then everything feels disconnected. At Farhat Lectures, we break audit down step by step. We explain the why behind the standards, the logic behind the assertions, risks, procedures, evidence, so the whole process finally clicks. When the concepts connect, audit becomes clear and manageable. You stop memorizing and start understanding. Ready for auditing to make sense? Start your free trial at farhatlectures.com. Measurement. So we're going to review real quick what's a standard deviation, enough that you need to know, as if you never saw it before: standard error, confidence level, and just sampling distribution, or the normal distribution. Let's go ahead and get started. Starting with the standard deviation or variability. Now, when I discuss variability, the easiest way for me to explain variability is, let's assume I have two classes, class A and class B. In class A, I pulled the first exam, I tested the first exam, the score is 95. I pulled the second exam, the score is 20. I pulled the third exam, it's 85. The fourth exam is 90. How confident am I in predicting the fifth exam? I'm not confident. Why? Because the scores are varying a lot. Now, if I take those 5 and it's 90, I would see the average is 70. I have class B. I graded the first exam 71, the second one 69, the third one 70, the fourth one 72. Am I confident to predict the fifth exam? And the answer, yes, I am more confident to predict the fifth. It will be around 73, 66, something like that. And if I average those 5, the average equal to 70. So notice, both of these classes, the average is 70. Both, if you take these 5 scores for class A and divide them by 5, they will give you 70. If you give these 5 scores and divide them by 5, they'll give you an average of 70. So the average is the same. However, the variability, how much these scores varies, each one student from the other, they varies a lot. And the range in this section, the range goes from 20 to 95. The range is 75. It's a high variability. versus class B, it ranges from 68 to 72, which is the range is 4. So when we have more variability, the standard deviation is higher. It means the population is riskier. Why? Because you never know what you're going to get next. The unknown is higher. So therefore, what we say is variability is more risk. Variable sampling assume that misstatements are spread around the average. So when we do variable test sampling, which we're going to see later and why, we assume that the misstatement are spread around the mean, not very far from the mean. Not all identical, but they are spread around the mean. Now we're going to measure that. So the standard deviation measures how spread are they around the mean. How spread? Are they close to the mean or far away from the mean? A low standard deviation means that they are close to the mean. They are consistent, like this one. So if we compute the standard deviation for class B, the standard deviation will be lower than class A. Class A will have a higher standard deviation. It means the data varies widely. They are spread a little bit further from the mean. More variability means more uncertainty, more risk. More risk means larger sample. Larger sample means more substantive testing, more work. This is what you need to know from standard deviation. Now, in the real world, what companies do, they stratify the data to reduce the variability in the data. What's a stratification? Stratification is dividing the population into homogeneous subgroup. Each group is tested separately to reduce the variability. And by reducing the variability, we reduce the sample size and we improve what we call the precision. Let's assume we are a utility company, like we provide internet access. We could be providing internet access to consumers, like people, household. We could be providing internet access to small businesses, and we could be providing internet access to enterprise, larger corporations. So we could have 3 groups of customers. We could have customers with their average bill internet per month $80. Small businesses, their average bill could be $600 per month, and we could be providing internet access to enterprise with their internet monthly tax bill is $5,000. Now when we audit, we don't mix them all together. We audit the consumer separately from the small business, separately from the enterprise. We stratify the data, and the reason is to reduce the variability, to increase the precision, to have a better lower risk when we are performing the audit. So this is most common when population have a mix of very large and very small items. We stratify the data. So this is what standard deviation is. And why do we need standard deviation? We need to know as standard deviation goes up, N goes up. As the standard deviation goes down, N as the sample goes down. And how do you reduce the variability for the group? We stratify the data. Also, we need the standard deviation to compute something called the standard error. The standard error. What's the standard error? The standard error, it's a number we're going to have to compute, tells us how much the sample mean, when we collect the sample, we can compute a mean, is expected to move from sample to sample. So if we select this sample, we have a mean. Then we select another sample, we have another mean. The standard error tells us how reliable is the sample result. If we pull another sample and a third sample and a fourth sample, how reliable is your sample results? So if the standard error is small, we can be more reliable. It means when we collect the other sample, it's very close to the prior one. It measures the accuracy of the sample mean as an estimate of the population mean. So if those samples are clustered together, all the means are clustered together, then we could say that we are dealing with low SE. It means the sample that we are collecting is a good representation of the population. How to compute the standard error is taking the standard deviation divided by the square root of the sample, where ST is the standard deviation, N is the sample size. Here's what you need to know, key point to remember. Higher variability, if we have a higher variability, if this is high, standard deviation is high, it means the SE is high. We don't want, if SE is high, remember SE is high, not emol, small. If SE is high, it means we have less
reliability. We are less reliable, less certain. If we have a larger sample, the more we can sample, the lower is the SE, because we're looking at more data. So the SE is used, guess what, to build what we call confidence interval. And the SE bridge between what the auditor observed in the sample and what the auditor estimate the entire population. So what happened is this: if we have a good SE, we can say that this sample is a good representation of the entire population. Auditors use the SE to calculate a confidence interval. And here's the formula for it. Confidence interval equal to X plus or minus the Z value times the SE, where X equal to the sample mean, Z is the confidence coefficient based on chosen confidence level, whether it's 68%, 95%, 99%, those are the three common ones, and the SE is the standard error that will be given to you. For example, let's assume the sample mean is 46, X equal to 46, the sample mean. Sometimes the average is, shown as U. The standard error happens to be 9, and the confidence interval is 95%, Z equal to 2. Well, let's compute the confidence interval for this sample mean misstatement of 46. If we take 46 plus or minus Z2 times the SC of 9 equal to 46 plus or minus 18, which is a large range. It means the auditor is 95% confident that the true average misstatement lies between 28 and 64. So this is what we're looking at. The average is 46, but we are 95% confident that the true average misstatement lies within 28, as low as 28, and as high as 64. Now this is a huge range, and the reason it's a big range because the standard error is 8. When the standard error is 8, it means we have a lot of variability in the sample. Now, later on, we'll work another example where one standard error is 1.5, Z equal to 1 will have a variation range around the mean of 1 plus or minus 1.5. A 2 will be a Z of 2 will equal to plus or minus 3. Let's assume in this situation we change the standard error to 3. So at Z equal to 3, what's going to happen now is we're going to look at 43. Let me change the color, and we'll work another example using these figures. So we're 95% confident. It's going to 95% confident. The range, the true average misstatements range below falls within 43 to 49. So plus or minus 3 from the average 46. We'll work another example using these figures. Now, let's look at this confidence interval, because the SE used to build what we call confidence interval. Let's see how the confidence interval works. Now, let's summarize everything that we know just to make sure we understand the full picture. Let's look at how these factors, confidence level, precision, tolerable misstatement, variability, and stratification, affect the sample size. If the confidence level, if we want more confidence, if you want to be more confident, you have to do more work. You have to select a larger sample. Why? Because if you want more assurance, wider is the Z, you need more items to make sure. If you want to be more confident, do more work. If you want to be prepared for the CPA exam, you do more work. It's as simple as that. More work, more assurance. Precision, how accurate you want to be. The more accurate you want to be, the larger is the sample size. You want tighter estimate, you must reduce the standard error. You need more items. This is how it affects the sample size. Tolerable misstatement, and we covered this in the prior session, tolerable misstatement. If you want smaller tolerable misstatement, remember, if you can tolerate smaller error, if you can only tolerate smaller error, you need a larger sample size. Why? Because if you want to be sure and your tolerable misstatement is lower, so if your tolerable misstatement is 10,000, you will do 5 units. If your tolerable misstatement is 5,000, you can only tolerate 5. You might have to look at 10 units. You have to increase more unit. More tolerance, less accuracy. If you want to increase the tolerance to 20,000, then you only need 3 units. Variability, which is measured at standard deviation. The larger the variability, the more variation, SE will go up, you need more work, need larger sample. Stratification. How does the stratification work? If you stratify, you need smaller sample size. You could reduce your variability, which is it means you reduce your SD. By reducing your SD, you reduce your SE. So notice SE is the heart of this relationship. More variability equal to more SE, need a larger size, and the opposite is true. Let's look at one more thing. The acceptance risk of incorrect acceptance. Risk of accepting a misstatement population. What does that mean? You may issue the wrong opinion. The risk of accepting a misstated population, it means you think the AR is okay, but it's overstated. The acceptable risk of incorrect rejection, risk of rejecting a fairly stated population. Well, you might have to do more work, but at the end of the day, you'll get to the right solution. So this is type 2, and this is type 1. I know we keep repeating this because it all fits together. Here you think inventory is misstated when inventory is actually fine. This is a type 1 error. So you rejected something. Now we have to understand something about the sampling distribution, and this is a core statistic behind variable sampling. Here's what we have to assume. We have to assume that we have a normal distribution, and if the auditor took many samples from the population and computed the mean would form a normal curve. A normal curve means something like this, a bell-shaped curve. It's symmetrical. It falls within a predictable range around the population. Within one standard error, 68% of the population falls. Means we are 68% confident that they fall within one standard error. Within 2, we are 95% confident. And within 3 standard error, we're 99.7. And this is important. It means the mean of all sample means equal to the true population. It means if we take the mean of all sample means, are we gonna look at all sample means? No way we're gonna look at many sample means. We're gonna only select one. This allowed the auditor to estimate the population using one sample, because if we keep on sampling, we're gonna get to the same thing. Therefore, we only need to take one sample as long as the population is normal. Keep in mind, the further you stretch the range, if Z equal to 3, the more sample means will fall inside of it. Of course, the more is the range. If the Z equal to 3, you're going to find 99.7% of the population. Now, the best way to illustrate this is to work an actual example with numbers. Suppose an auditor select 50 invoices and calculate their sample mean. And the sample mean is 40. Fair enough. But the auditor wonders, if I took another 50 sample, would I get the same sample mean? What do you think? 50 samples out of, let's assume, 10,000. Most likely not. Most likely not. But if the population is normally distributed, they may get 40 for the first one, 41, 39, 42, 38. So each sample will have a different mean, but they all fall within a symmetrical distribution. If you draw a graph of all those sample means, you will get a bell-shaped curve, something that looks like this. Remember, they were all around 40. The sample means will be close to the true population mean. So we don't know what the true it's going to be close, but we don't know what is it exactly. Few sample means will be very high or very low. Fewer, but the majority will be around that means of the mean, and the curve would be symmetrical, something like that. This curve is what we call the normal distribution or sampling distribution or normal distribution. If you average all these samples means, the result would equal to true population mean. And this is the magic of sample distribution. So when we discuss ratio estimation, means estimation, difference estimation, it's all based on this theoretical statistical theory. Assume the true population mean is 40, but the auditor does not know the true population mean. So auditor takes one sample and the sample mean equal to 40. Now, but the auditor don't know what the true population mean is. It's just we don't know that. But let's assume we got it and we are 40. And based on the standard deviation, our standard error is equal to 1. And with one standard error, it means the average will go between plus and minus 1.5. So the confidence interval, how do we compute the confidence interval at 65? We say plus minus one standard error. Start with the average, plus or minus 1.5 means 38.5 to 41.5. We are 68% confident that the mean falls between 38.5 and 41.5. Now, if we want to be more confident, if we want to be within two standard error, which will give us 40 plus 3, 3 is correspondent with the 2 standard error, we are 95% confident that the mean falls between 37 to 43. Now, the true mean is 40, but we don't know that. But with 95% confident, we can say that. If we go with 3 standard error, we can say with almost certainty that the true mean falls between 35.5 and 44.5. Now, notice, if you want to be more certain, we're going really outside the range. So using one sample, the auditor can conclude, I'm 95% sure, so we're going to go with this statement, I'm 95% sure that the true mean of all 10,000 invoices is between 37 and 43. That's a high confidence. Now, if I want to be 99% confident, I would say it's between 35.5 and 44.5. Although we only tested 50 invoices, we can make this conclusion. And this is the magic of normal distribution, standard error, and standard deviation. Now, looking at all of these, we can start to kind of cover the variable sampling, how we can compute variable sampling in 3 different ways: through difference estimation, ratio estimations, mean per unit estimation. What we're going to do, we're going to cover those separately, and we're going to start from this slide on the next session, because first I wanted to kind of build the ground, just make you understand or help you understand why difference estimation, ratio estimation, and mean per unit are valid methods. Now let's take a look at this multiple choice question from farhatlectures.com. Which of the following changes will increase the sample size in variable sampling? Now, if you are using farhatlectures.com, you could always ask the AI to say, could you explain to me what's, increase in sample size, what could lead to increase in sample size? It will explain it to you, then you can come back and try to answer the question. Otherwise, if you know the answer, let's go ahead and answer the question. High tolerable misstatement. So if we have a tolerable misstatement of 10,000, if we have a higher tolerable misstatement, if we can tolerate now, rather than 10, we can tolerate 12,000. If we have a higher tolerable misstatement, okay, 12,000, what's going to happen to our sample size? As our tolerable misstatement goes up, our sample size goes down. Why? Because if we can tolerate more, we can do less work. Our sample size goes down. Therefore, if we said lower, that will be the answer, but not higher. A is out. B, higher expected variability in the population. If we have more variability in the population, do we have to increase the sample size? And the answer is yes. The more variability, the more is the size, the more work we have to do. That's why when we have variability, the first thing we try to do is to stratify the data so we could reduce variability, therefore we can do less work. Otherwise, we have to do more work. Between A and B, I'm going to keep B. Let's look at C. Lower confidence level. If I can live with a lower confidence, I don't have to do a lot of work. Therefore, if I want lower confidence level, I can decrease my sample size. The opposite is true. If I want more confidence, I have to increase it. Lower is wrong. Auditor wants a wider precision interval. No. If I want a narrower precision interval, I have to do more work. Wider precision interval, I have to do less work. Therefore, wider is incorrect. Therefore, as we suggested, as we guessed, the answer is B. Now, if you don't like this answer choice, you could ask AI to explain the correct and incorrect answer. And if you like this question and you want to test it in a different way, ask AI, farhat.ai, to give you a different question. What should you do? Go to Farhat Lectures and work more quizzes, more multiple choice, look at podcasts, review lectures, invest in yourself. That's the best investment you can make, whether you are a CPA exam candidate or an accounting student. Invest in yourself, stay safe, and God bless.